Okay, everybody, this is a new set of videos. Obviously, this is video number 1 on function transformation. Let's get started here. So as you can see here, this is a typical parabola, right? A quadratic, as we call it. This is a graph of y equals x squared. Okay? And the purpose of this video, excuse me, is to make sure you understand how basic transformations of this quadratic works. So basically what a transformation means, guys, is imagine instead of y equals x squared, I did y equals x squared, let's say, plus 1. X squared plus 1. Let me be a little bit neater there. Well, what would that do to the graph? Well, just think of it. If I add 1, I'm going to make it 1 larger, right? And so as you'll notice, that vertex will move up 1 space, and so my parabola will be exactly the same size but will be 1 higher. Likewise, imagine if it was y equals x squared, let's say minus 2. And of course, if I'm following my graph here more correctly, negative 2 is right there, and a minus 2, in other words, would lower everything by 2 spots, and so my parabola would be 2 lower. Now let's look at some examples to be more specific. As you can see right here, follow the green. The one in red, as you can see, is my y equals x squared. Follow the purple now. The one in blue, notice, is y equals x squared minus 4. So if you notice the blue graph right there, notice how the vertex moved down. It moved down 4 spaces, didn't it? It did a negative 4 on us. So again, that's what a minus 4 will do. Likewise, follow the gold. The green graph is y equals x squared plus 3, and what do you know? If you look up here, the vertex actually moved up 3 spaces, a positive 3. So a plus something will move it up, a minus something will move it down. Pretty simple. Pause the video if you need to. Okay, let's take a look at these 4 graphs. We'll start with gold here. Notice the first graph, y equals 9x squared. And look at the red graph right there. What do you notice about that graph? Hopefully you'll notice that that graph goes up. It's skinnier. It goes up a lot faster. Why? Because when I put a coefficient in front of my x squared like 9, positive 9 is going to make that thing grow 9 times faster. Okay? Now likewise, follow the green this time. Look at the blue graph. The blue graph actually is down here. Now again, notice the vertex is at negative 4 again. Why? Because my function says minus 4 at the end. Notice also the blue graph is not quite as skinny as the gold, or I should say red graph that we started with, right? Why? Because it's only a 2x squared, not a 9x squared. So in other words, the coefficient, basically, the larger the coefficient gets, the skinnier it gets, the more stretched it gets. And that's a common phrase you ought to get used to. Stretched. Okay? Continuing on. Follow the red. Notice the green graph. And it's starting to get a little messy, so let me clean up here first a little bit. Here we go. Again, you can always rewind or pause and replay the video some other time. But notice the green graph right here, guys. See how much wider it is, right? And notice the vertex right there is at positive 3. See that plus 3, and the function moved it up 3 spaces. Now why is it so wide? It is because notice my coefficient is a 1/4. You see, the smaller I make that coefficient in front of x squared, the wider it's going to get. It's going to grow slower, you see. Now finally, let me erase all that I've made a mess of there. And let's go back to gold here. The final graph, you'll notice in orange, is right here. The minus 1, of course, moved it down one space as discussed before. And since it's a regular x squared, a 1x squared, notice it takes its usual shape that we've been doing on most of our graphs. But anyways, guys, that's basically how transformation works. Pause the video if you need to. Okay, let's go to one final set and put it all together. You'll notice there's 3 graphs there. We'll start in order, follow the gold, the red graph right there. And before we look for the graph, actually it's purple or lavender, let's just analyze the function itself. Notice the 1, the plus 1 at the end. What's that going to do? It's going to move it up 1. Notice the 9 in front. What's that going to do? That's going to make it grow faster, so it's going to get skinnier. The other thing different is notice the minus 4, x minus 4. Well, what did I teach you in class? Didn't that mean 4 minus 4 was 0? Right? Well, since it really indicates a positive 4, notice now, let's go to our graph over here. Didn't it shift over 4, positive 4 to the right, because positive is to the right, negative to the left? Did it not shift 1 up? And the reason again was the minus 4 indicates a plus 4 to the right. The plus 1 means 1 up. Now hopefully that makes sense to you. Let's go to red, the purple or bluish graph there, I should say, in which I'm now going to mark in red. Let's look at the function first. Notice the minus 2. Well, what did that do? It moved it down 2 spaces, didn't it? It moved it down 2 spaces. Okay? What did the plus 5 with the x do? Well, think. Isn't negative 5 plus 5 0? Notice from the origin it moved 5 to the left. So plus 5 means 5 left. The minus 2 means 2 down. Notice the 2 in front. Well, notice this shape is not quite as skinny as the original one, but it's a little bit skinnier than what a normal quadratic or x squared would look like. Now finally, let's look at the green one. Let's look at the green. Again, you can always rewind and replay this video, right? If you look at the green one, I'm going to go back to gold again. It seems to show up a lot. Look at the function first. What's that plus 3 going to do? Move it up 3 spaces, right? What's that x minus 1 going to do? Well, positive 1 makes it 0. So notice if I come over here, it did shift positive 1, meaning 1 to the right. Notice the 1/4 in front. What does that do? Well, notice the overall shape is wider, right? Because a 1/4 again is going to make it grow slower. So pause the video one last time, guys. Okay, so guys, without me running way too long, the whole point is this is definitely a video you ought to watch over again. Study it, understand it. You're going to need this in IM3 and Trig Pre-Calc. Okay, until next time, bye.